Hello, my name is Marcus Kidike. This is assignment 1 for Comp 3132, also known as Machine Learning course. And for the introduction, we have Fashion M and IST, which is a data set. And we're going to import the libraries, the data set, and the train test models. Now, we're going to go through each of the 21 questions, and we're going to answer them in this video. So what are the dimensions of these labels? Well, do the dot shape. These are our dimensions. 60,000 by 20 by 28 for training image, 10,000 by 20 by 28 for test images. And what are the lengths of these labels? Well, 60,000 for training, 10,000 for testing. And we're going to show these labels by printing the first 5 rows. And we're going to print the digital content image of index 5 in the training dataset. So here is the digital content. We're going to plot it and we're going to print it. So what is the label for index 5 image? It is label 2. And what does this mean? It means that it is a pullover. So this image of index 5 is a pullover. Now we have testing images with testing dataset using index 500. Same thing. We're gonna print the digital content, plot it, and print the label. So what is the label for the 500? It's number 2, which is a pullover. These two are pullover images. Now, I'm going to import these models and layers from the keywords library. I'm going to define a sequential model and call it my network. We're going to flatten it. We're also going to divide it by 255. And we're going to add 3 hidden layers. One hidden layer has 112 neurons. The other one has 128 neurons. Both of these are using the ReLU function. So I'm using the ReLU function, so let me print them. And the last one uses a different function, which is called softmax. And why do we use softmax for the last layer? Well, softmax ensures a clear decision by making the probabilities interpretable. So it helps with training stability as the probabilities make loss calculations smoother. That's why we use softmax for the last layer. And how does it work under the hood? So it takes a vector of the raw scores and converts them into probabilities. And the class with the highest probability is chosen as the final decision. That's how softmax function works under the hood. So essentially, softmax being used as the activation function in the last layer of a neural network for a multi-class classification problems because it outputs a probability distribution over all possible classes. That's why it is used as the last layer. And we have 2 models, model A, model B. Both are using, what do you call it? One using Atom, one using RMS prop. We're going to run this question. So we're going to compare. We're going to run both model A and model B. So we're going to set the number of epochs to 10. So here, let's run 10. And while that's happening, I'm going to answer these 2 questions. So how do you compare Fashion M and IST to what we learned in class? So Fashion M and IST dataset is basically clothing items. That's what it is. So it's t-shirt, trouser, pullover, dress, coat, sandal, shirt, sneaker, bag, and ankle boot. While as a standard M and IST is just handwritten digits. So 0s, 1s, 2s, 3s, or 9s. That's what they are. Now, what can we infer from the difference in accuracy? Well, the accuracy of model A is higher than model B because model A uses the Atom optimizer, which is a popular optimizer for deep learning. Atom is a combination of the momentum and RMS prop optimizers, which are both popular optimizers for deep learning. And the momentum optimizer is a technique that accelerates the learning rate of the optimizer by using a moving average of the gradient, while as RMS prop optimizer is a technique that uses the root mean square of the gradients to compute that learning rate. Now we're going to use the evaluate function to achieve the accuracy and loss over the test image labels. And do we have an overfitting? So as you could see, they are pretty similar, but the test loss for model B, is for model A is a lot higher than model B. So if the test loss is much higher than training loss, that means there is an overfitting. But because test loss is lower, there is no overfitting. Same thing with this one right here. They are almost the same thing. So yes, there is no overfitting for these two models. And that's it. Thank you for watching. Have a good day.